You're listening to A Climate Change. This is Matt Matern, your host. I've got Steve Fambro, CEO of Aptera, on the show. Steve, thanks for joining us.
Thanks for having me.
Well, I want to just, a little background for the listeners as to what Aptera is. It's an electric car company that has been going for a while, and I got interested in it when I saw the cars that you had developed and that they could be charged directly from the sun, and that they had the photovoltaic cells on the car, and it kind of looks a little like a spaceship. And then I read further and saw that you are shooting to have batteries that have a charge that could last for 1,000 miles for one charge, which also is kind of a bit revolutionary. So tell us a little bit more about this revolutionary car that you've been developing at Aptera, and when are we going to see it on the road?
Sure. Just to set the timeline. So Chris and I actually restarted the company in 2019. We had started Aptera originally back in 2006, and we raised some money, brought in a professional management team, and it just didn't work out. So we left the company, and he went on to start a battery company, Flux Power, and took it public. And I got into farming because I love food. And that took me to the Middle East, where I did some work for one of the big families there, and came back to the U.S. With my family in 2017, and we restarted Aptera a couple of years later because we saw that the market had changed, that electric vehicles weren't just a curiosity, that everybody wanted them and they couldn't make them fast enough. How we got the 1,000-mile idea was after we did some analysis on sales of electric vehicles. We saw that among several factors, range was one of the big driving factors in sales volumes. And so we thought, why not maximize the range as much as possible? And we did some calculations and determined that with some of the newer battery formats, the larger 4800 series cells, that we could pack in enough batteries, about 100 kilowatt hours, to go 1,000 miles. So that's how that happened.
So where are you at currently in development, and when can we expect to see the first kind of cars out on the road for purchase?
We've just finished a major design lockdown on basically every subsystem, but most importantly, the body and carbon. And that's key because it's the largest, most expensive tooled surface of the vehicle. Lots of other things can be adjusted after the fact. You know, if a bracket doesn't fit, then we can make a new bracket or adapt it somehow. But getting the suspension, the closures, as they're called, doors, windows, that kind of thing, and the body in complete design lockdown that's what we've been working on for the past year. We've just passed that milestone. So now we've got, I'd say 6 months ago, we purchased some very expensive blocks of tooling steel from Germany. They're massive, they're bigger than people. And the steel is going to be machined into tools in Italy at our supplier, CPC. So those blocks had to be purchased about 6 months ago because of how long it takes. They've just been delivered a couple of weeks ago. And very soon they're going to start machining those tools to begin making the body structure. And we expect the first test bodies to roll off the line mid-year this year, and production vehicles ready to be sold by the end of the year.
Wow, that's moving fast in comparison to in the car world. It takes years to kind of design and create a new car, from my understanding. It's tell us a little bit about the photovoltaic cells that are on the car, and how those work, and how much electricity is likely to be generated from them, so that this car can go without plugging in to operate.
Yeah, we use Maxion cells. And when we restarted the company in 2019, the state of batteries and solar cells had made massive improvements. These cells didn't exist back in 2006 when we first started the company. And so once we discovered these cells, and once we figured out a way to bend them in part of a structural panel, we calculated, how much energy we could get just from having the roof solar. And Chris and I were, I had MATLAB on my computer, and we were doing these calculations and simulations. And we said, we could get a couple of miles extra range a day if we have this solar roof. Isn't that great? And then the light went on in our head. Our body's surface is so smooth. Why not how much could we get if we cover the whole body in solar cells? And so that was the genesis behind that. And we determined that we could get a peak solar power of about 700 watts, and over a period of a day, about 4 kilowatt hours. And because our vehicle's so efficient, we use 100 watt hours per mile compared to like the new Hummer. I think it uses 700 or 800 watt hours per mile. Because we're so efficient, 4 kilowatt hours translates easily into 40 miles. And so that's how we came up with that. And once we committed to that, the solar actually became the largest part of our IP portfolio. It's the most research intensive part of our business because nobody's doing what we're doing the way we're doing it. There are some other companies with solar cells on the vehicles, but our panels are, I think, the lightest weight, probably the lowest cost, most robust. They're very damage tolerant. You can put a bullet through it and it'll still produce power. It'll just be reduced by a little bit. You can hurl ice cubes at it and softballs and it still keeps functioning. So developing that and then making it manufacturable at high scale, and then making it to automotive standards where it's going to last for 10, 15 years, vibration, salt, snow, freeze thaw cycles, that's been a large part of our R&D effort.
Well, that is a fascinating possibility to get 40 miles from just sitting in the sun. And obviously there are certain parts of the country and in the world where we get a lot of sun, and you could do almost all your driving without ever plugging the car in, just having it sit in the driveway or on the road picking up energy. So that could be revolutionary. I assume this is just the start in terms of you're at 40 miles now. I assume it's going to go up over time.
Yes, the solar cells are going to get more efficient. We're also going to have different models with different amount of surface area, and we're also working with some other companies to commercialize sort of a fledgling solar mobility business, leveraging our technology for other customers, and looking to monetize that. So it's not just our vehicle; it's other vehicles, it's other applications that our solar can really help lower the impact of electric vehicles on the grid. By doing this, we're able to deploy lots of electric vehicles and electrify lots of things without necessarily having to worry about bringing the grid along to modern standards. Sure, we need a modern grid, of course, but not having it is not a reason to wait on electrification, and that's really one of the benefits of Aptera.
So in terms of financing a car company like this, I understand there's a tremendous amount of capital that's required to launch this. Where is the company at in terms of its current capital and what its needs are going forward?
Elon Musk, I think, said he called his factories money furnaces or something like that. We're not at that stage yet. I don't think we ever will be because our vehicle is fundamentally different than a car. A typical car body, or body in white as it's called, has 200 structural pieces that all have to be fixtured and welded together and held dimensionally constant during that process. Our structure has 6 pieces. So fundamentally, we're just clicking 6 pieces together as opposed to trying to hold 200 pieces together and keep them aligned. So our development time for the body is shorter, our assembly line cost is less, our tooling cost is less. Everything is different. because of what we call the new steel, the pressed carbon. We're not, you don't have any labor in this part. You're not having to put fiber in the thing. You basically just put a block of carbon paste in the mold. It squeezes shut with 5,000 tons force, add some heat, and 3 minutes later, a structural part comes out ready to use. So fundamentally, our costs are different because they're lower because we have fewer parts and fewer tools. That said, to date, we've raised about $100 million, and that $100 million has let us develop the vehicle from scratch with all the other attendant technologies, sort of the solar, as I mentioned, the solar electronics, the battery. We made an acquisition last year of a company that makes displays and the software because they did a much better job than we could. And we've been able to do all of that on less than $100 million. To get to production, we're out in a Series B raise right now for $150 million. And we've got folks in Saudi Arabia and the United Arab Emirates, in Europe and the United States that we're talking to that all want to be a part of this.
Well, it's an exciting future that you're talking about here. You're listening to A Climate Change. This is Matt Matern, your host, and I've got Steve Fambro, CEO of Aptera, on the program. Aptera, new solar electric car company, and we'll be right back with Steve to talk more about the revolutionary technology that his company is bringing to the market soon. You're listening to A Climate Change. This is Matt Matern, and I've got Steve Fambro, CEO of Aptera, the newest of the electric car companies, and I think an exciting one. Steve, you were telling us about this Series B that you're looking to fund for $150 million to get you to the next level. How much of that has been funded, if you can tell us, and how much more needs to be funded to kind of get you to the production phase or through the production phase?
Yeah, we've I'm not sure what I could talk about publicly, but we've got I would say a significant investment from a strategic supplier, and we also have the public California CEC grant for $21 million that we applied for. It was a competition, and we were one of several companies awarded that kind of grant. So that's a matching grant, essentially. So every dollar that we spend, they give us $1 back. So it's already a big chunk of the raise that's been helped, by these two investments. But I think if we can keep our fundraising on schedule, and I don't see why we can't, we should be able to get the vehicle into production, go through all of our validation, crash testing, everything next year, and hopefully out to the market.
That'd be great. Well, I think from a public policy point of view, I certainly endorse the state of California and other governmental bodies like the U.S. government getting money out to market-leading tech or manufacturing type companies to continue to have California and the United States lead the world in these technologies. And sometimes the market needs a little push and it to take the types of risks that you're taking in starting a new company that's a little bit different than what we've seen in the past. And so all the things that you're talking about, just the manufacturing of the car, could lead to, kind of be revolutionary for manufacturing in general, as well as car companies. 6 parts instead of 2,000 is pretty incredible shift. Is any of that through like 3D printing, or is it totally different processes?
It's different process, but I just want to hop back real quickly on the government funding. In this case, California, looking to keep manufacturing in the state of California. So we're very proud and thankful to be able to compete and have won that grant. But as a free market capitalist myself, you're often our first reaction is, hey, we don't want government involvement at all. But when you look at the competition, when you look at China, you look at Germany, Korea, those those countries are heavily subsidizing those industries. So if we want to compete, we have to compete at that level. There's just no other way around it. Tesla is a great example of a company that I think flourished from the original loan, and then they paid it back ahead of schedule. And now, how many billions of dollars of wealth has been created by them? How many jobs have been created? So I think that's a great example of how that kind of government assistance can work. Your question after that, give me.
Oh, well, in terms of revolutionizing the manufacturing, I think you kind of answered it in saying you don't use the 3D printing, but the other, maybe you could explain to us a bit more about this manufacturing process of pressing the carbon, and is that really that new just for the car industry, or is it new in general?
It's new for the car industry, and this particular process is new in general. Let me just give you a brief background. So when Chris and I first met, I was working on composites to build the first Aptera. He was using composites to build his wakeboard boat. He had a wakeboard boat company at the time, and we were using a resin infused sandwich core composite structure. So there's layers of fiberglass and then foam, like a PVC foam, and then another fiberglass layer. And it's all infused with liquid resin. Well, we had since optimized that process using very fast UV curing resins so that we could make a structural part in minutes. We could make an entire body part and structural part in several minutes. But there's two big drawbacks to that. It's great for lower volumes. I'd say between 100 and 1,000 per year. Beyond that, it just doesn't scale. And so this was a process that we were thinking of using when we first restarted the company, because we did not believe we would get more than 1,000 pre-orders per year. So we got 1,000 pre-orders in the first day or two. And now we're almost 40,000. And so a year ago, we had to, we were scratching our heads to say, we can't scale this process. Even as fast as it is with the UV cure resin and everything else, it can't scale the way it needs to scale. And so we dispatched our VP of engineering, Akosh Fair, to find us a process that was scalable. And he went around the United States and Europe and brought us this company. And he called me on the phone. He said, they won't let me take pictures, but you got to believe me. You have to come here and see this. You're just not going to believe it. This is everything we wanted. So Chris and I took a flight the very next day, got to Italy, saw it, and we were blown away. And the process it's a form of carbon SMC, a sheet molding compound. So it's carbon fiber and a resin matrix. It looks like black Play-Doh or paste. And they simply just put blocks of it in the mold, and the tool squeezes shut, and a couple of minutes later, the structural part comes out. But what they do, CPC, our partner, that no one else does, is they make these structural parts for cars, for Maserati, for Lamborghini, Ferrari, and they design them for them, and they do all of the analysis for them. And so they have this whole ecosystem of not, they're not making SMC trash cans or SMC other stuff. They have this entire ecosystem of design, testing, simulation, validation, everything for these carbon composite structural parts that nobody else in the world has. And on top of that, they can then take those parts and build them into the vehicles. So they're actually contract building these vehicles, just like how Valmet is, I think, building for Lightyear. Magna Steyr is building for Fisker. CPC builds vehicles for other companies. I can't mention them. That's company confidential, but they do the same thing, and they have the skills in-house to take it from end to end. So it was transformative for us because we had this composite process that we fell in love with, that we created, but it just couldn't scale because of labor and all the paint and sanding and things like that. And with this new process with CPC, we're able to just produce as many as we could as if it were a steel part. We call it the new steel because it's better than steel. It's lighter, it's stronger, it's recyclable. It's recyclable, I think, up to 5 times. as a structural part. So it's unlike any other composite that people are familiar with.
Wow, that does sound revolutionary. In terms of how it's made, is it you're talking about it being made out of carbon? Is it taking carbon, atmospheric carbon, or what carbon is it using? Is it kind of sustainable, more sustainable than, say, steel?
Well, to date, most carbon fiber is actually the precursor compounds, PAN, come from oil. So the way we think about it is this is just like plastics and Tupperware and things like this. This is another use for oil that's not burning oil. So by using oil for this, we're taking it out of the market and using it for something that is other than burning. And so that's how we look at it from that perspective. You'd have to do an analysis of what it takes to mine the ore to begin making the whole steel, like the whole steel process, and compare it. We've done some of that, and I still think that this carbon is very competitive in terms of overall carbon footprint compared to the end-to-end steel footprint. But I don't have anything that we can share with the public right now. Before we put numbers out, we like to be very, very sure and careful that numbers are correct. But most carbon fiber does start its life as oil. In the future, could that change? Could that be extracted from the atmosphere? Who knows? That's great possibility. I would love that. But at the moment, we're starting from oil.
Okay. Well, I guess you're working with a company, CPC, that's working with Lamborghini and Ferrari. Those are good, solid car company names. And your car has a very sleek look. It's kind of spaceship X. How did you how did you come up with that design, and why the kind of pod shaped look of your vehicle?
When I wanted to build an electric vehicle back in California, I did some initial calculations, and I talked to people that had converted some electric cars, which was a thing to do, 15 years ago, because you couldn't buy one. And I discovered that most of them don't go very far. They went 30, 40 miles on a charge. And when I started doing the analysis of where the energy goes, I saw right away, well, over half of the energy goes to just to push the air out of the way. Just the shape of the vehicle, pushing the air is what uses most of the energy at highway speeds. So I had this thought exercise where I said, well, how do we, like in engineering, you'll make a variable go to zero or infinity. And so I said, how do we make the drag go to zero? What does that shape look like? And that started me on a path of discovery, which resulted in this cambered body.
Well, it's a beautiful looking car. We're talking to Steve Fambro, CEO of Aptera. We'll be right back after this break. And you're listening to A Climate Change, and I've got Steve Fambro, CEO of Aptera, exciting new car company. And Steve, you talked about the 40,000 pre-orders that you have for the vehicle. I have to disclose that I am one of those pre-orders. So
they told me.
Yeah, I really liked both the design of the car, and I love the fact that it can charge, can kind of go off grid, as well as the 1,000-mile charge. All those things are amazing, and it's kind of challenging the status quo in so many different levels. It's a fantastic kind of revolutionary vehicle. Tell us a little bit more about the design and how you came up with it. You were telling us a bit before the break, and I'd like to hear more about that.
So when the light went on in my head, I mean, I was an electrical engineer at the time. I worked for a biotech company here in San Diego, Illumina, and when the light went on, that if we could make the drag somehow go to zero or lower it by an order of magnitude, then we could have, we could increase the range by a factor of 10 of an electric vehicle on the highway. And so that, I'm also a pilot, and I was looking at different kit airplanes to build. So I'm somewhat aware of aerodynamics. So I I bought all the books I could buy on aerodynamics and aerodynamics for vehicles, ground vehicles. And I started looking at the books for the solar racers, the ones that, or the eco marathon, the Shell eco marathon, where they go like 1,000 miles, 2,000 miles on a gallon of gas. These little aerodynamic coffin looking things where people lay down in them and they go around a track. So I started looking in that direction, and I realized that the vehicle aerodynamics for something in the air and what they call the free stream is very different than when you approach the ground. That's in ground effect. The air behaves differently, and the vehicle has to be designed differently to take advantage of that. And that's really the genesis of how we got started. We started with a cambered body, which originally was developed by Dr. Morelli in Italy. And we took that cambered body and started working with our designer, said, how do we make this into a road vehicle? How do we fit two people side by side in it? How do we change it to make it more stylish, but not increase the drag? So we started using computational fluid dynamics, and we needed to validate the design. We needed a stamp, something that when we were talking to investors that they would believe us. And so we hired NASA Langley to simulate our vehicle in their low-speed wind tunnel in their CFD processing center. Back then, CFD was a really big deal, required lots and lots of computers. Now it can be done on a desktop or Amazon servers. It was the first check we wrote starting the company. It was like $15,000 to NASA to do this study back in 2006. And they said there's some problems, and they wanted to get us on a call. And so Chris and I were on a conference call with like 10 NASA engineers, and they said, what wizardry are you guys using? How is this possible? There's no way the drag of this vehicle can really be 0.12 or whatever it was at the time. And we said, well, you're NASA, you're the experts, you tell us, that's why we hired you. And it was one of those aha moments where we said, and these guys are very smart. I don't mean that in a negative way. I mean, they're NASA, right? They can put people on the moon. But we realized that as a company, this was something we couldn't outsource. We had to own it. We had to have aerodynamicists in-house. We had to build a cluster, Linux servers to run the CFD software, because because NASA was so perplexed. We said, we just have to know everything about this. We have to own this segment. We did the same thing with solar, basically creating this entire department for solar and electronics and everything else. But that efficiency, the lightweight, the composites, and also the low drag, it means that our vehicle uses, a third, maybe a fourth of the power per distance of a typical electric vehicle. And that's better for everybody, because that's fewer batteries, that's less cost, it's fewer mining resources that have to be used. It means it's more affordable. So this relentless, almost like dogmatic pursuit of efficiency within our company really enables the vehicle to go a long way with very little batteries, with a fraction of batteries that any competitive product has.
Well, I think that's a real revolutionary kind of concept, which is to have vehicles that are, more commuter vehicles. I mean, this is a commuter vehicle. It's not hauling a lot of stuff, but I mean, probably 90% or 95% of our trips as drivers are spent in solo trips, or maybe with two people. We're not hauling a lot of bags or anything like that. That's why this technology is so useful for us. We're wasting a lot of energy by driving big cars that are not aerodynamic, correct?
Well, absolutely. The EV truck wars, I don't think, is where the environment needs to go. We don't need mining batteries has a cost. There's an environmental cost with everything that humans do. So we have to be mindful of it. And steering the technology to use fewer and fewer resources is really how engineering has been done, electrical engineering especially. Transistors get more efficient, they get smaller. That's the natural progress of things. So to see 10,000 pound vehicles full of batteries just so they look like a regular truck or SUV that people are used to. I don't think this is the way. I don't think this is sustainable. It's going to require extraordinary amounts of power to be brought to different charging locations. It's going to take a long time to charge. It's going to use a lot of batteries. It feels like the wrong direction to us. And so that's why we're going in the opposite direction, or a direction that uses fewer resources, it uses them wisely, it stretches them out over a really long distance and gives a customer, I think, a really good value.
So in terms of the CPC, the company that is making these new carbon fiber parts for you, where do you see this going? I mean, is this new process that they have, is that something that any other company on the planet can do, or is it kind of a patented technology? And where do you kind of see this going, in the future? And why did they pick you to work with when their normal customers are Lamborghini and Ferrari?
CPC has been growing their business. It's one of these quiet companies that people haven't heard about. And I joke every time we go back there, there's a new building, there's a new campus, something is new and bigger and better about them. They just completed a 12-story tower, which is now the new office. They do supercars well, and it's made them a lot of money. And it's a great segment that has grown them to where they are. But they are looking at companies like Aptera or Tesla and seeing this growth in electric vehicles, and they're saying, wait a minute, electric vehicles really have to be mindful of weight, because they're all trying to lightweight. They're making structures out of aluminum. They're starting to use composites, and they're saying we've been doing that all along. So we want to go after this new industry, and our technology. I'm using CPC's voice. CPC's technology gives them the ability to scale at really high volumes, unlike composites has been able to do so in the past. And so the relationship between Aptera and CPC lets them really demonstrate that at scale. They can talk about it all day long, but if they can produce an affordable electric vehicle that's extremely lightweight, that is indicative of the process or representative of the process that they would use to do other vehicles for other companies, that's what they're also trying to achieve. They're going to have a lot of business with Aptera, and they're going to make a lot of money with Aptera. But they're also looking, beyond who are the other companies that they can continue to grow their business with even higher volumes. Aptera, even at 40,000 units a year, is still low volume compared to Detroit standards. There's lots of vendors in Detroit that wouldn't even take meetings with us because our volumes are just too low. They don't do anything below 100,000 a year. So that's another reason why we ended up going to Italy, is there is this ecosystem of suppliers whose volumes are right around our sweet spot. Their sweet spot is right around our volumes, I should say. But CPC is instrumental in that, because there's nobody else in the world that can do high volume automotive composites the way they do. These parts have fasteners that are built in them. They come out ready to be covered with a vinyl wrap. They don't have to be treated or sanded or polished or anything. They are really, I would say, their tribal knowledge and their trade secrets and whatever other IP they have let them make these automotive parts in a way that nobody else in the world, from my knowledge and my research, can do.
Well, it's pretty fascinating. Certainly the Italians are masters at design and have built some of the best cars in the history of car making. So great partners to have on any project. You're listening to A Climate Change. This is Matt Matern, and I've got Steve Fambro, CEO of Aptera, on the program, and we'll be back in just 1 minute. You're listening to A Climate Change, and I've got Steve Fambro, CEO of Aptera. Steve, exciting times for you and the company. How many people are currently working for the company, and how many people are you going to need as the company goes into production of the vehicles?
Here in the U.S., we have about 100 folks under our roof between our solar facility just a couple miles down the road and here at the headquarters. Overseas, mostly in Italy, we have probably another 20 to 30 people, maybe 50 or so through various vendors that we're working with. So suspension, lighting, aluminum castings, that kind of thing. To get the vehicle in production, the team in Italy will grow by about 30 folks. And our team here will grow a little bit less than that for the final assembly, because we're going to be doing the body assembly in Italy first and shipping the bodies over here, probably with the suspension and wheels on it, where we'll put on the glass, we'll put on the solar panels and that kind of thing. That final balance of what we're going to do in Italy versus what we're doing in California hasn't been decided yet, but our original plan had us only hiring about 40 people for the factory here. It's going to be a little bit less than that. At a 12-minute tack time and 40 vehicles a day, it's just, there's not a lot of people that are needed. Most of the engineering will increase for validation, testing, et cetera. Some of that will be outsourced through our partners that do that kind of work, Roush, et cetera. But some of those engineers will be full-time in-house. So you're probably going to see that climb up to about 300. And if you tell that to anyone in the automotive or startup electric vehicle industry, they'll laugh. They'll say, "There's no way you can do it without, that's so small." But again, we're not building a traditional car. We're building a much simpler vehicle. It has fewer parts. A lot of our partners are validating these various systems for us. So there's much less work that we have to do than a typical company who says, I don't want to. There's other EV companies who maybe they've hired thousands, tens of thousands of people to do all of these tasks in-house. We just don't have to do that. We have competent partners that can do that, some of that stuff better than we can, and we leverage that.
So in terms of vehicle production, you had said 40 vehicles per day. I was just doing the math. That's about, 1,200 vehicles a month, 14,000 vehicles a year. Is that your target? Where do you see this going in the future?
It's 40 vehicles a day per shift for this building. The decision and what that gives us is it gives us a starting framework that we can demonstrate here and then either copy or scale. It remains to be seen based on all the different economic variables of energy, labor, everything else, if the optimum assembly for this vehicle is 2 or 3 facilities around the United States or one big facility somewhere central or on the East Coast. That calculus isn't clear to me yet, which one of those are better. I know the way the industry goes for a single facility, and they do that because it's highly capitalized and they can't afford to distribute, to copy that capitalization everywhere. But our vehicle doesn't have that. It's assembled very differently. I think about it, when the parts come in from the suppliers, it's almost like taking flat packs of IKEA furniture and just deciding where you're going to put it together. You probably want to put it together really close to where you're going to use it, like in your living room or in your kitchen or wherever. You don't want to put it together some distance away and then ship that product to there. So that is our strategy, is to have the subassemblies kitted and packaged from the vendors so that we can literally bolt this thing together anywhere in the world. And there's all kinds of advantages and reasons why you'd want to do that. Not the least of which are tax advantages, depending upon the country that you're either building in or importing into, et cetera.
Wow, that is fascinating, because that is truly revolutionary, to put together kind of a car like a piece of IKEA furniture. I realize you're simplifying it quite a bit, but still, it's to stand up a manufacturing facility of a vehicle is usually a multi-billion-dollar equation, and to do it for far less than that is revolutionary. It's expending a hell of a lot less in resources, and if we're talking about sustainability, that goes a long way. as we were kind of discussing, one of the things kind of off air was using less of this carbon fiber than you would of steel because it is stronger, so at a magnitude of 2, 3, 4 times stronger. So you using less material as well in making the vehicle.
That's right. And I think that's most engineers, most companies that make products to engineer a product, they really only want to use the amount of material or the amount of stuff that's necessary. They don't want to overdo it. Nobody does. But in our case, we could have made our original Alpha vehicles that you've seen driving around. Those are 100% structural composites. So there's no steel or metal coming from front to back in the vehicle. It's just the entire composite structure carries loads. And there's pluses and minuses of that. There's reasons, why you'd want to do that or you wouldn't. In our case, what we found is although we could make a technically lighter part with our sandwich core process, I mentioned to you earlier, it wouldn't scale. That's a big reason. The second thing is that you can't accurately model it in a finite element analysis. You can kind of model it, but because it's the material is discontinuous, use an engineering term, you've got sort of hard interfaces of fiber and resin, and then a core, and those are all discontinuous. It's very those are all what they call edge effects in finite element analysis, and it's very difficult to model that. So what it means is you have to do a lot of destructive testing to characterize a part, and companies do that all the time. But the advantage of going with CPC is that their material is homogeneous, and so it's well characterized. It's isotropic. It has the same reactive nature with force in any direction, as opposed to a composite panel, which is stronger in one direction versus the other. So we give up some of that weight benefit to have something that can be modeled easily. And that lets us really fine tune and reduce the amount of materials that's needed. And then we can start playing little games where you say, well, what if we make the battery pack structural, and instead of having that structure in the carbon, then we can make the carbon tub thinner and make it cost less, because that was the most expensive part of the materials. So we've used aluminum. We have castings that sort of connect the vehicle and the structural battery pack together. And we've been able to do that to lower the amount of carbon that we make the vehicle out of, to lower the overall cost. We could make it out of more carbon and get rid of the aluminum, but it'd be a little bit higher cost. And we don't want to do that. So we're trying to have the optimum of performance, weight, and also cost. And this material and CPC in their process lets us do that in a way that we could not do it with sandwich core composites.
Well, tell us,
compared
Steve,
to
sorry to interrupt you, Steve, but tell us about the 3 main objectives of the company over the next 3 to 12 months as to the challenges you face to kind of get the vehicles out the door and into the hands of the public.
The 3 big milestones, I would say, are wrap up our Series B fundraising, begin kicking off some of the high expense tools, both for the body and the motor. We've got to get in the order queue for some of the battery welding robots. So we've closed a round of funding. We can make all those orders, and then start getting body panels off the tools about mid-year to July, maybe. And then once we're getting body panels off of the tools, we will have already had our castings and all that other stuff done. We can start testing the vehicle, sort of privately, not in the public, but doing the brake validation, crash testing, that kind of thing, because we'll have a manufacturing representative product, structure, body that's made off of production tools, made with production processes, and that's what we can characterize and validate. So I would say wrap up the Series B, place the big purchase orders that we're waiting to do, and then start getting body panels off the tooling about mid-year, July, sometime that time frame, so that we can start doing some of the final validation.
So how much are these high expense tools that you're buying?
Oh, uh, not as much as a regular car company, but a battery, let's say an ultrasonic welder for the battery cells is about $250,000 a piece, and the best companies in the world that make them are German, and so and everybody wants them, and so there's a queue, and we need we need several of those. I say several, I mean a little bit cheeky, more probably 10. But that gives us the ability to make 40 packs a day per shift. All of these tools also can run multiple shifts, so that the 40 a day really comes from one shift. So the easiest way for us to scale is simply to start a second shift, because the tooling that's why car companies have 2 and 3 shifts, just so they get maximum return on that capital equipment.
Right.
So by going to a second shift, we'll double the output.
Right. So you could maybe take the 30,000 and then maybe 45,000 cars per year, which would be great. Well, Steve, great talking with you. Steve, running the car company, Aptera, Steve Fambro. Thanks for being on the show. It's been a pleasure, and look forward to having you back sometime later this year to hear good news about where the company's gone.
I look forward to it too.
Okay, well, you've been listening to A Climate Change. Please tune in next week.